pose with the bands.
The motherboard or mainboard is the main component and the most important computer component because it is on the motherboard that are processing and storage component are flashed and connected to each other. The main component of the mainboard is the printed circuit board (PCB), which houses all other important components such as CPU, VGA, USB, and so on. The motherboard functions as a place to provide access for all existing computer components to connect to each other so that various data instruction, input and output processes can occur.
CPU, Central Processing Unit, is the main component of the computer that functions as the brain of the system, responsible for processing data and executing instructions from software. Every computing activity, such as opening application, typing, or running game, is controlled by the CPU. Here is detailed explanation of the CPU. First, main function of the CPU. 1. Fetch. The CPU retrieves the instruction from the main memory, RAM. 2. Decode. The CPU translates those instruction into a form it can understand. 3. Execute. The CPU perform arithmetic or logical operation as instructed. Send the result back to memory or other device. Second, main component of the CPU. 1. ALU, Arithmetic Logic Unit. Handle arithmetic operation such as addition and subtraction, and logical operation such as and, or, not. 2. CU, Control Unit. Manage the flow of instruction, control the operation of a computer part, and ensure data move correctly between components. 3. Register. Small high-speed storage are inside the CPU used to temporarily hold data during processing. Third, how the CPU works. The CPU operates in a fetch, decode, execute cycle, meaning it repeatedly fetches data from memory, interpret the instruction, and execute them at extremely high speed. Fourth, CPU performance factor. 1. Clock speed. Measured in GHz, it shows how many instruction cycles the CPU can complete per second. 2. Number of cores. More cores allow the CPU to handle multiple tasks simultaneously, multitasking. 3. Cache. A small, fast memory inside the CPU that speed up access to frequently used data. In summary, the CPU is the central control and processing unit of the computer system, determining the speed, efficiency, and capability of the device to run various programs.
RAM is a hardware component in computing device that provides temporary data storage space for operating system processing, software or application processing, and other data processing. The purpose of RAM is to store temporary data so that it can be accessed quickly by the processing unit or processor in computing device such as computer. Thus, RAM is responsible for storing data that will be supplied to the processor. Among several types of memory, RAM is classified as primary memory because it plays a role in facilitating computing process in computer. RAM usually has faster data read and write speed than hard disk. However, data storage in RAM is temporary or volatile. RAM only stores data while the computer is on. If the computer is turned off or lost power, the data stored in RAM will also be lost. There are several functions of RAM that you should know about, namely storing temporary data, helping to speed up processing, supporting multitasking, providing space for multitasking, and facilitating graphic processing.
Power supply is the part of the computer that gives power to all the other part of the computer. It changes the electricity from the wall into the kind of the power that the computer needs. The functions of the power supply. It sends the right amount of the power to each component of the computer. It keeps the power steady and safe so that the computer doesn't get damaged. It has a fan to make it stay cool and protects the pictures from short circuits and overheating.
Definition of hard disk. A hard disk or hard disk drive is a hardware device on a computer that serves as permanent data storage media. Data stored on a hard disk remains intense even when the computer is turned off, as it is a type of non-volatile storage. The hard disk consists of fast-spinning magnetic platters and read or write heads that record and retrieve data from the platters. Here are the hard disk functions. The first, permanently storing the computer operating system so it can be accessed when the computer boots. The second, storing software, application, and programs. The third, saving files and documents such as photo, videos, music, and other data. The fourth, providing backup storage to recover data in case of loss. And the last, serving as primary or secondary storage media in computer or laptops.
Okay, now we are moving into how to assemble all the component parts and build a PC. Step 1. Before you begin, make sure you have a clean, well-lit workspace. You will need a Phillips screwdriver, some cable ties, and ideally an anti-static wrist strap to avoid damaging your components with static electricity. Lay down your case, motherboard, and all parts neatly on the table. Make sure you have grounded yourself. Just touch a metal surface or the PSU metal body to discharge static. Step 2. Installing the CPU. Start with your motherboard on a flat surface. Locate the CPU socket, either AM4 or EM5 for AMD or LGA 1700 for Intel. Lift the small retention arm on the socket, then align the CPU's golden triangle with the triangle mark on the socket corner. Gently place the CPU into position. It should drop it naturally without any pressure. Once aligned, lower the latch back into place to secure it. Okay, here's the pro tip. Never touch the CPU pins or the metal contacts, they are extremely delicate. Step 3. Applying thermal paste and mounting the cooler. Now, apply a small pea-sized drop of thermal paste onto the center of the CPU. Then take your CPU cooler, either the stock one or a third-party model, and align it with the mounting holes around the socket. Press the cooler gently into place and secure it evenly with screws or clips done over time. Okay. Finally, connect the cooler fan cable into the CPU fan header on the motherboard. Step 4. Installing RAM. Next, find the RAM slots on your motherboard. It's usually labeled A1, A2, B1 or B2. Open the latches on the both sides, align the notch on the RAM stick with the slots, and press firmly until you hear a click sound. Repeat for the second stick if you have to. Step 5. Installing the M.2 SSD. Locate the M.2 slot on the motherboard. Insert your SSD at 30-degree angle. Then press it flat and secure it with a tiny screw provided. This drive will hold your operating system. It's extremely fast and compact. Step 6. Mounting the motherboard inside the case. Now it's time to place your motherboard into the case. Install the I/O shield, the metal plate that covers the rear port, first. Then align the motherboard screw holes with the standoff in the case. Once aligned, carefully lower the motherboard into positions and tighten the screw diagonally. Just snug, not too tight. Step 7. Installing the power supply. Flip your case so you can access the bottom area. Position the power supply so its fan faces downward if there's a ventilation, or upward if not. Slide it into place, line up the screw holes and secure it tightly. Route the major cables through the back for a cleaner build. Step 8. Adding storage driver. If you are also using a 2.5 SSD or 3.5 hard disk, mount them into the drive cages or trays inside the case. Connect a SATA data cable to the motherboard and SATA power cable from the power supply. Step 9. Installing the graphic card. Locate the top PSI 16 slot on your motherboard. Remove the corresponding metal brackets on the back of the case. Then insert your graphic card, strike into the slot until it clicks. Secure the GPU with screws, then connect the PSI power cables from the PSU to the GPU. Make sure your GPU is properly seated. This is a common first-time mistake. Step 10. Connecting the front panel and cables. Now it's time for the small connectors such as power switch, reset switch, power LED and hard disk LED, front USB and audio headers. These tiny cables come from the case front panel. Consult your motherboard manual for the exact pin layout, cause every board is slightly different. Step 11. Cable management and cooling system. Good cable management is key to both airflow and aesthetics. Use the case rear side to route cables and tie them neatly using cable ties. Install your case fans. Front fan should pull air in for intake. Rear and top fan should push air out for exhaust. This ensures cool airflow smoothly through your system. Step 12. This is the moment of truth. Plug in your monitor, keyboard and mouse. Connect the power cable to the power supply and flip the switch on. Press the power button, your system should light up and spin all fans. Enter the BIOS by pressing the LED or F2 during startup. Check if all components are detected such as CPU, RAM, storage devices, GPU. If everything looks good, proceed to install your operating system such as Windows or Linux via USB.
One, compatibility between components is important. Ensure all components can work together seamlessly. 2. Performance must match user needs, such as for gaming, graphic design, or general work. 3. Energy efficiency help reduce electricity costs and environmental impacts. 4. Accidental triggers solve the debate of property, including budget, physical space, and long-term needs.